Now let's look at the margin of error. In reality, you want to decrease margin of error so then you can make fairly confident business decisions. But when you decrease margin of error, you're also affecting other items. So if you decrease the margin of error, the confidence level also decreases. Because remember, in your normal distribution, if you're making your level decrease, the percent that is captured in there decreases. So then the number of standard deviations you go out is also decreasing. So you can see in this illustration a 95% confidence interval versus an 80% confidence interval. It's decreased. You're not capturing as many values. Also, the sample size increases. So just a side note for you, this is coming up in the next sections. Margin of error, one part of the margin of error is the standard deviation. And remember, for proportions, for a sampling distribution, the standard deviation is the square root of 1 or p times 1 minus p divided by n. And for averages, it's the standard deviation of the sample divided by the square root of the sample size. So in both cases, sample size is in the denominator. So if this is one factor of margin of error, meaning I'm going to multiply this by something, as n increases, this value of standard deviation decreases, which then makes the final product smaller, which makes margin of error smaller. So increasing sample size decreases the margin of error. The margin of error does not account for any source of bias in the data collection process. We've talked about non-response, under coverage, voluntary response, things like that can lead to bias. None of this part of constructing an interval accounts for that. That is something that when you collect data, you have to determine whether this is an outlier. Should I include this or should I not? So at this stage, none of that is being accounted for unless it was taken care of in the beginning. So for a normal distribution extending about 2 standard deviations, remember we were talking about 95%. About 3 standard deviations is approximately 99.7%. So a more general formula, and this is actually on your formula sheet verbatim, the more general formula for a confidence interval is your statistic plus or minus the critical value times the standard deviation of a statistic. Remember, your statistic here, this is your point estimate. Critical value is the new thing, that's what we're about to talk about. And standard deviation, well, this depends on if it's a proportion or a mean, just from chapter 7. All right, so let's dive into critical value. So the critical value is a multiplier that makes the interval wide enough to have the stated capture rate. This is your number of standard deviations out. But again, this is extending about 2 and 3 standard deviations. So 2 and 3 are not the exact values that we will be using. So as part of a project about response bias, Ellerly surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud. Based on the responses, Ellerly said she was 90% confident that the interval from 3.14 to 3.52 captures the mean GPA for all students at her school. So explain what would happen to the length of the interval if the confidence level were increased. How would a 90% confidence interval based on a sample of size 200 compared to the original 90% interval? And describe one potential source of bias. Well, the confidence for A, the confidence interval will be wider because you're increasing the confidence level, which increases the margin of error. For part B, the confidence interval would be narrower because increasing the sample size decreases the margin of error. Then the margin of error doesn't account for the fact that many students might lie, right? Because they're just saying their GPA out loud. If my GPA was 2.7 and the 4 people in front of me said 3.8, 3.7, am I really going to say my number? I would be embarrassed. So they might lie about their GPAs when having to respond without, so the mean GPA for all students might be even less than 3.14.